with stoichiometry, and we're going to go to 3 steps, which is the most that we'll go. So we're going to be adding molar mass as a conversion factor. Does anybody remember what the units are for molar mass? Grams, exactly. Grams per 1 mole. So today that's going to be the conversion factor that we're adding along with the mole ratio. All right, so if you'll look at your notes first, we're going to do a little bit in there, not too much. All right, we were right here. Beyond the mole, real stoichiometry. So we're really not learning anything new. We're putting things that we already know together. So it seems like it's new, but we're doing things with the mole ratio, which we've already done, looking at the coefficients, molar mass, balanced equations, dimensional analysis where we use a box. So all things that we've already done, and we're just putting them together. So remember that 1 mole of any substance equals the molar mass of that substance. And we're going to use this as a conversion factor. We'll be using this along with our mole to mole ratio as a conversion factor, which is our coefficients. So our steps that we're going to work with, we're going to write a balanced equation. That's usually probably going to already be done for you. You need to identify your known. And remember, that's what's given to you in the problem. That's going to be what has the number attached to it. And your unknown are what we're trying to figure out. We always start with our known, just like we did with our mole ratio. And we're going to line up our needed conversion factors, which are either going to be mole ratio or molar mass. You can take out the part that says volume at STP. We'll do that whenever we get to gas laws. Then once you get everything set up, because these are going to be 3 steps, then you're going to calculate the problem. And remember, you multiply across, and then you take whatever you have at the top and you divide by what's at the bottom. Check your answers. All your units should cancel out except for your unknown. And don't forget your units on the answer. So I can't just have a number. You got to be sure that you put your unit on this. All right, so let's look at some problems. There's also 4-step problems. We're not going to do those. We're just going to do 3-step problems. That's going to be the longest that we're going to do. All right, does everybody have that? I'm going to have to scoot up a little bit. Yes, we're good? Okay. So I'm going to skip example 1 and example 2. And then I'm going to kind of get you to change up example 3. So for example 3, instead of doing mass to volume, we're going to do mass to mole. So where it says how many liters, if you'll say how many moles. And once again, don't worry about this STP. So mass is the same as grams. So that if this is going to be a gram to mole problem, that means my given is in grams and my unknown, what I'm trying to figure out, is going to be in moles. So that's why we call it a mass. Grams is the same as mass. A gram to mole problem or a mass to mole problem. We're going to have to use 1 molar mass in this. So first of all, check and see if your equation is balanced, which it is not. What do we need to do to balance that equation? If I put a 2 here, and I put a 2 here, I think that'll be balanced. Is that balanced? 4, 5, 6. All right, good. My mind didn't really want to think about that too much today. All right, so it says, how many moles of oxygen? So that means that is my unknown. I'm going to put a U under it for unknown. Are used to produce 75 grams of sulfur trioxide. So that's going to be my known. So we're not worrying about SO2. It's still just like when we did our mole ratio. We're only worried about 2 things in the equation. You're saying here is what you're saying, where I had the 2. Then we'd have 2 sulfur in here. If I have 2 times 2 is 4 oxygen, 5, 6. Yeah. It's because it looks, yeah. All right. So my known is my sulfur trioxide. My unknown is my oxygen. So we're going to use that other sheet that you picked up today. We're going to use that to help us get through these problems. So for my virtual students, this is under notes. It's called a Stoichiometry Roadmap. And it's going to help us use our either mole ratio or our molar mass to solve these problems. We are only using this middle portion. Mass, notice on this side, this is your known side, this is your unknown side. So if your known is given to you in grams or mass, you would start right here. And every time you come to a box, you don't need to outline your box, but every time you come to a box, that tells you what you're going to multiply by. So this box is a molar mass box. The circles are nothing to multiply by. That just tells you where you're at. This here, second box that's right in the middle, that's my molar ratio box, or that's when we're looking at our coefficients. Once again, moles of unknown, that's not a multiplication box, that's just telling you where you're at. And then your last box here would be the molar mass of your unknown, because now you're on your unknown side. So let's look at this equation that I had. 2 SO2 plus O2 gave me 2 SO3. And we said that this was my known. The oxygen was my unknown. I did not need this. And my given was that I had, what was my, bless you. Too many notes going around over here. My given was that I had 75 grams of my sulfur trioxide. Okay. So my given is in grams, so that tells me I'm going to have to start right here. And so you're going to take your given mass and you're going to put it over 1. So that's going to be 75 grams over 1. If I put something over 1, it does not change the number. So now I go to this conversion factor, and this conversion factor says multiply by 1 over the molar mass of my known. So I would have to figure out the molar mass of sulfur trioxide. And when I did that, it would be 80.07 grams. Okay. And you'll notice on the, whenever you start on the worksheet, I've given you the molar masses, so you won't have to calculate those separately. So then that tells me if I stopped right here and I did a calculation, I would know how many moles of my known that I have. But I don't want that. I want moles of my unknown. So I need to go to my next conversion factor. And my next conversion factor says multiply by the mole ratio with your unknown being at the top and your known being at the bottom. Remember that is just coefficients. So my known needs to be at the bottom. How many moles of my known do I have? 2. Remember, this is my known, coefficient of 2. How many moles of my unknown do I have? Which is oxygen. 1. I'm going to set my equals because when I do this calculation, I'm going to stop right there, and that's going to tell me my moles of my unknown. So I'm going to do 75 times 1 doesn't change it. So then I'm going to take 75 and I would divide it by, put this in parentheses, 80.07 times 2. So why don't y'all try that so you can make sure that you get it in your calculator right. Did you divide by 80? Did you take 75 and divide it by 80.07 times 2? I got 0.47. Is that what I got? Nope. Yes, some no's, yes. So my answer for this would be 0.47 moles. So there's 2 ways to work these problems. Either you can just memorize the order. If I start in grams, I'm going to use the molar mass first. And then I'm going to use the mole to mole ratio. Or you can use this sheet to help you get through it. I was given grams. That's what I was given, and I wanted to get to moles of unknown. So I had to use 1, 2 conversion factors to get me there. All right, let's look at another one. All righty. We'll go back to all right, we'll look at example number 4. And this one does need to be balanced, and this was a big pain to balance. When you balance it, you need a 4, a 5, a 4, and a 6. So this one says how many grams of oxygen, so that's my unknown, is used when 85 moles of ammonia react. So ammonia is my known. I don't need this or this. So my given is in moles. And I'm trying to get to grams. So this is a mole to gram problem. I'm going to start a little bit different place on my sheet. All right. Let me get over here to my little cheat sheet. All right. And this problem was 4NH3 plus 5O2 yields 4NO plus 6H2 2O. And this was my unknown, and this was my known. I didn't need anything. And we said our known was in moles, so this is a mole to mass or mole to gram problem. Since my since my given is in moles, I don't want to start over here with mass. I want to start right here because that's what I know. I know how many moles of my known I have. And I want to get all the way over here, which would be mass or grams of my unknown. So we're going to be starting at two places today. If your given is in grams, you'll start here. If your given is in moles, you'll start here. So we're going to start here. And it says that we have 85 moles. So just like we did, I'm going to put 85 moles over 1 to get started. My first conversion factor I come to right there is in the box that says multiply by the mole ratio, which is just the coefficients. It says you have your unknown at the top right there and your known at the bottom. So how many moles of my unknown do I have? 5. And how many moles of my known do I have? 4. If I stopped right there and I did that calculation, I would know how many moles of my unknown, but we don't want to know that. We want to know mass. So I've got to do one more conversion factor. It says multiply by the molar mass of your unknown over 1. So I would have to figure out the molar mass of my oxygen, which is 16 times 2. So that would give me 32 grams. And I put it over 1, just like it says to in that conversion factor. And now I've set it up. So we're going to do 85 times 5 times 32. And here I have only 4 on the bottom. So that should have given you 3,400. And my units always come from right here. So 3,400 grams. This 32 came from getting the molar mass of oxygen. And since it's diatomic, it was 16 times 2. Like I said, you'll see when we start on the actual worksheet, I've given you the molar masses that you need, so it saves you a little bit of time. So this little sheet is real handy for what we're doing today. Whenever we were doing just our mole-to-mole problems, which is what we had done right before, we only had to use one conversion factor. We didn't use any molar masses. But now we've kind of made that larger. So we're either going to be starting here if our given is in grams, or you're going to be starting here if your given is in moles. All right, let's look at some of the ones on your worksheet. Those are good examples. So if you go to your daily work, for my virtual students, if you go to your daily work, if I get this underneath. How is that blue? So I've done a couple of things to make this easier for you today. Number one, I've put all of one kind together. So you'll see the first 5 are one kind, the second 5 are a different kind. So that's going to make it easier. Also notice that I've given you a molar mass, the molar mass that you need. So that's also going to make it easier for you. So a couple of things that'll make it easier that way. All right, I have to make this larger. All right. So let's just start with number 1. it says, here's my balanced equation. It's already balanced. All of the equations today are already balanced. How many grams of hydrogen? So hydrogen is my unknown. I'm just going to circle it in red. I don't really have enough room to write on it. How many grams of hydrogen are needed to completely react with 2.5 moles of nitrogen? So there's my known. I don't need either of these two things. All right, so if I take that problem, I'm just going to put it on my little thing one more time, my little cheat sheet. And it was N2 plus 3H2 yields 2NH3. But we did not need that. This is my known. This is my unknown. My known is given to me in moles. It says I have 2.5 moles. And I want to figure out how many grams of my unknown. So this is a mole to gram problem. So since my known is in moles, I want to start right here. So I'm going to take my given 2.5 moles and put it over 1 to get me started. So I come to my first conversion factor, and it says multiply by the molar ratio. So I'm going to be multiplying, and these are just coefficients. The molar ratio of my unknown at the top by known at the bottom. So let's start with my unknown. How many moles of my unknown do I have? 3. And how many moles of my known do I have? 1. All right. So that got me past that. That just tells me if I stopped right now, I was at moles of my unknown, but we need to get all the way over here to mass or grams. So I got to do another conversion factor. So it says multiply by the molar mass of the unknown. Well, my unknown is hydrogen. And if you look on your sheet, I give you the molar mass. It says MMH2 is equal to 2.02 over 1. That's what it tells me to do. It tells me to put the molar mass over 1. Now I've got it set up, so I just need to do my calculations. 2.5 times 3 times 2.02. Nothing on the bottom, so I don't need to divide by anything. What'd you get? 15.15? That's it. So those first 5 are going to follow that same pattern. You're going to start with your moles. You're going to have your coefficient or your mole ratio. And then you're going to have your molar mass over 1 at the end. And I've given you all the molar masses to make it a little bit easier. So let's jump down and look at the other steps. Because from 6 to 10, then they're switched. My given is in grams, and I want to get to moles. So if I look at number 6, I'm just going to go ahead and write it out here. Yields 2 KCl plus 3O2. And it says how many moles of potassium chloride, so that's my unknown, are produced if 25 grams of potassium chlorate decompose. So this is my known, and I have 25 grams. I don't need my oxygen. So this is a gram to mole problem. My given is in grams, and I want to get to moles. So if my given is in grams, I have to start over here. Remember, mass and grams are the same thing. How do you know which one? Your known is always going to be the one that has a number in the problem attached to it. See how it said 25 grams in chlorate? So that has to be your known. And then your unknown is what you're trying to find. And this one said moles of potassium chloride. So that means that's my unknown. The only thing it didn't say anything about was oxygen. So oxygen was the thing that was not needed in this particular problem. Oh, I just skipped down to number 6 under the different kind. All right, so let's start with our given, which is 25 grams over 1. That's right here. So my first conversion factor, it says I multiply by 1, so the reciprocal, but 1 over the molar mass of my known. And my known is KClO3. And if you look on your paper under number 6, I've given you the molar mass of that, so you don't have to calculate it. That 122.55. So that's my first conversion factor. If I stop right there and get a number, that would tell me how many moles of my known I have, but I don't want that. I want moles of my unknowns. I need to go through one more conversion factor. And it says I multiply by my mole ratio. You're always going to do your mole ratio. And my mole ratio is the coefficient of my known over my, of my known on the bottom, unknown on the top. So how many moles of my known do I have? 2. And how many moles of my unknown do I happen to also have? 2. I put my equals, and now we do 25 times 2 divided by 122.5. Remember down here, if you got a couple of things, you're going to have to put in parentheses. And I got 0.204, and my units would be moles, because that's what we're looking for. So those last 6, 7, 8, 9 are going to follow this pattern. I'll start with my given grams, and I'll use that molar mass on the first step, but it'll be on the bottom, and then I'll use my mole to mole ratio. All right, you got to kind of just jump in and give them a try. Like 2 or 3 places past the decimal sign. These will be the longest ones that we do. We won't do any longer than this. Virtual students, do y'all have any questions I can help you with? All right, well, we're just going to continue to work on this.